Day 2, Problem 1. Identify the slope and y-intercept for the graph of y equals negative 1/4 x plus 3. This equation is in a particular format called slope-intercept form that makes it very fast to find the slope and y-intercept. When an equation is written in this form, the letter y alone, then equals, then the x term, and then the constant term. The coefficient of x, that is the number multiplied to x, is the slope. And so the slope is negative 1/4. And the y-intercept is the constant term. So the plus 3, the positive 3, that is the y-intercept. And so Part B, graph the equation, can be done quite quickly using these two values that we've identified, starting with the y-intercept. If you think about what y-intercept means, that is a dot on the y-axis where a line will pass through. And if the y-intercept is 3, that is telling us that there is a dot on the y-axis at 3. And here is that dot. Now the slope, negative 1/4. This number is telling us how the line is sloped, or how the line is angled when drawn on the grid. Some lines slope like this, some lines slope coming downhill like this, and that slope is given by this number here. Now a slope of negative 1/4 means that when the value of x increases by 1 unit, that is when you move from one dot and go 1 unit to the right, then the value of y, in this case, is decreasing 1/4 of a unit. And let's do that. To the right 1, and then I'm going to go down 1/4 of a unit. Now, here is half of a unit down, and more like right here would be 1/4 of a unit down. Okay. We can repeat this. Over 1 and down 1/4 more. That would take us finally to halfway. We can repeat this again. Over 1 and down 1/4. Maybe right here. And again, over 1 and down 1/4. Finally, we are down to that next grid line. Okay. Down 1/4, down 1/4, down 1/4, down 1/4. 4/4 in total has finally taken us down 1 full unit. There's one other interesting thing to observe here. Because it's so difficult to take guesses at these fractions, especially when the grid squares are fairly small, do you notice that when the slope is negative 1/4, that we could think of that as going down 1 unit, right, the negative 1, and then notice how the 4 is 1, 2, 3, 4 full units to the right. So that's another way to think of down, or the slope of negative 1/4. Instead of trying to come down by these little fractional pieces, we could have come down 1 unit, that's the negative 1, and then over 4 units. And that would have been the positive 4, getting this dot here. And our line is like this. Now day 2, problem 2. The table shows a person's weight during a dieting program. Assume the relationship between the quantities is linear. Find and interpret the rate of change and initial value. Now, rate of change. How does the value of y change as the value of x changes? We're going to find this by looking at the rows. We can look at any 2 rows we want, but for instance, we might look at this row and this row. From 0 to 2, 2 months has gone by. And during that 2 months, the person's weight has gone from 185 pounds to 181 pounds. He has lost or decreased 4 pounds, negative 4. Writing that as a rate of change, negative 4 pounds in 2 months. Now this is reducible. -4 pounds in 2 months, when reduced, means -2 pounds in 1 month. And it is this comparison that is rate of change. How does the value of y change when x changes by 1 unit? This could also be written as -2 pounds per month. Now the initial value. Think about what the initial value would mean in the context of this story about a person's weight. It's asking, how much does the person weigh to begin with before they start the dieting program? Now mathematically, that is asking, what is the value of y? That is, what is the person's weight when x is 0? That is, before they started dieting at all. Well, in the table, it actually gives us 0 for x. And so whatever the value of y is that's associated with x is 0, that is the initial value. And in this problem, that person was 185 pounds to begin with. And so our initial value, 185 pounds.